Every year, more than 16 million tons of sugar are consumed across the globe. Producing such an enormous amount of the sweet ingredient is far from simple. Behind every grain lies a powerful industrial process. But have you ever stopped to wonder how sugar is actually made? Today, we step inside a sugar factory to uncover the complete process of how sugar is produced from sugarcane. If you enjoy discovering how everyday products are made, like the video and subscribe for more factory stories. Once the command is issued, the heavy cavalry moves in. These combine harvesters are not just cutting grass, they are performing surgery at 5 miles per hour. As they glide over the rows, rotating base cutters shave the stalks flush with the ground to maximize yield, while topping knives sever the leafy crowns. But here is the constraint that drives this entire industry, the ticking time bomb. The moment a stalk of sugarcane is cut, it begins to die. Natural bacteria and enzymes immediately attack the open wound, converting your valuable sucrose into useless acid. If this cane sits in the tropical sun for more than 24 hours, the profit evaporates. To survive, the harvest becomes a synchronized dance. Notice how the tractor trailer matches the speed of the harvester perfectly. They collect tons of raw material without ever stopping the wheels. It is a continuous flow of biomass, tracked by GPS and barcoded for total traceability. The goal is simple: get it to the mill, use it all. As the convoy reaches the factory gates, the drivers hit a checkpoint. In the sugar business, you don't get paid for the weight of the grass. You get paid for the sugar inside it. A truck full of waterlogged, low-quality cane is worthless. Enter the core sample. This hydraulic needle drives deep into the heart of the truck bed, extracting a cross-section of the cargo. This is the moment of truth for the farmer. Inside the laboratory, the sample is crushed under high pressure. Technicians analyze the juice using refractometers and polyrefractometers. They are looking for pull and bricks, the gold standard of sweetness. This data feeds directly into the factory's central brain. It determines the farmer's paycheck, but more importantly, it tells the engineers exactly how to tune the massive machines for this specific batch. The factory is about to digest 50 tons of raw material, and it needs to know the recipe. Logistics complete. Now the violence begins. At the tipping bay, hydraulic platforms lift entire semi-trucks into the air, creating a landslide of cane. It is dusty, loud, and chaotic. Cane hits the main carrier belt, a river of green moving toward the mill. First, it must pass the iron police. Look closely at the conveyor. That suspended block is a powerful electromagnet. It's hunting for stray metal, a lost wrench, a tractor bolt, or wire fencing. If a piece of steel entered the high-speed machinery, it would destroy the rollers like a bullet in a jet engine. The magnet snaps them up, protecting the front. safe from metal, the cane enters the shredder. This is the loudest room in the facility. Heavy-duty hammers spinning on a rotor at hundreds of RPM smash the cane against an anvil. We aren't trying to juice it yet. We are trying to obliterate the plant cells. We turn the hard stalks into a soft, fluffy, fibrous blanket. Why? Because you can't squeeze a rock. You have to soften it up first. The shredded fiber now enters the milling train. This is a series of massive grooved rollers exerting thousands of pounds of hydraulic pressure. The concept is simple. Squeeze the fiber until it weeps. To ensure they get every single drop, the mill uses a technique called imbibition. They spray hot water onto the fiber as it moves through the final rollers. This hot bath dissolves the last stubborn bits of sugar clinging to the plant cells, washing them out into the collection trays. The result is a river of dark, murky liquid known as raw juice. It looks nothing like the sugar in your kitchen. It's green, acidic, and full of soil. Meanwhile, the dry fiber, called bagasse, exits the back of the mill. In most industries, this would be garbage, but here, this waste product is about to become the most valuable asset in the building. While the fiber burns, the raw juice begins its own journey. Right now, it's chemically unstable. The natural acids in the juice can destroy the sucrose molecules within minutes. We need to neutralize it. The juice is heated to 75 degrees Celsius and mixed with milk of lime. This triggers a chemical reaction. The lime latches on to the proteins, fats, and field mud suspended in the liquid, causing them to clump together. The mixture is pumped into the clarifiers, giant, silent tanks where gravity takes over. The heavy limed mud sinks to the bottom, while the clear golden juice rises to the top. It's a purification process that transforms swamp water into a pristine amber liquid. The mud at the bottom isn't wasted either. It's filtered one last time and sent back to the fields as nutrient-rich fertilizer. The cycle of nature continues. We now have clear juice, but it's 85% water. To get crystals, we must boil that water away. But sugar is sensitive. If you boil it at 100 degrees Celsius, it will caramelize. You'll get burnt toffee, not white crystals. The solution is physics. The juice enters a series of vacuum evaporators. By lowering the air pressure inside these silver tanks, the liquid boils at a much lower temperature, around 65 degrees. We can boil the ocean out of the juice without ever burning the sugar. As it moves through the vessels, it thickens into a rich syrup. It is now pumped into the vacuum pans for the most delicate step of all, crystallization. The operator injects a solution of microscopic sugar dust called seeds. Instantly, the dissolved sugar latches onto these seeds. Under the microscope, you can see them growing layer by layer, building the geometric structure of the crystal. This is the birth of the product. What drops out of the pans is massacute, a heavy brown magma, a mix of pure crystals trapped in a sticky web of molasses. To separate them, we use brute force. The mixture is dropped into centrifugals. Imagine a perforated basket spinning at 1,200 revolutions per minute. The G-force is immense. Watch closely. The liquid molasses is ripped away from the crystal, forced through the fine mesh screens. The crystals are too large to pass. In a fraction of a second, the color changes from dark brown to a pale gold. A quick blast of steam washes off the final film of molasses. The dark sludge has been transformed into raw sugar. The molasses is piped away to make animal feed, yeast, or ethanol, while the crystals head to the refinery. To create the sparkling white sugar found on your table, there is one final stage. The raw sugar is melted back down into a liquor and passed through activated carbon filters. This absorbs the last microscopic traces of plant pigments. Recrystallized once more, the sugar is 99.9% pure sucrose, but it's wet and hot. It passes through rotary granulators, long drums where warm air blows through the tumbling crystals. As they dry, they separate, gaining that free-flowing quality. Finally, the crystals pass over vibrating screens. They are sorted by size with laser-like precision. Only the crystals that meet the exact specifications are allowed to move forward. Anything too big or too small is melted down and sent back to the start. The final leg belongs to the robots. High-speed automation fills, seals, and stacks the bags, preparing them for a journey across the globe. From a stalk of grass fighting for survival in the field to a perfectly preserved crystal of energy, this process is a triumph of industrial engineering. It is efficient, self-sustaining, and essential. This is the sweet science that powers our world.